Hello and welcome once again to our series on mathematics. In this lesson, we are going to look at integers. Let's assume this boy has 5 Ghana cedis and this boy has 2 Ghana cedis, and they both go to a shop to buy a shirt. The shirt costs 3 Ghana cedis. The first boy can buy the shirt and have a balance of 2 cedis left with him. The second boy, however, cannot buy the shirt because if he buys it, he will end up owing 1 Ghana cedis. This is the idea behind the use of integers, that is, having negative numbers. In mathematics, we normally have numbers which include 0, and then we have whole counting numbers, namely 1, 2, 3, 4, 5, and so on. These are all whole numbers. But in maths as well, we can also have numbers which are negative, or numbers that are less than 0. We call this negative numbers. So what are these numbers? We rewrite the whole numbers in the opposite of the left. Negative 1, negative 3, negative 4, negative 5, and so on. So in effect, we can as so this means you need 3 has because it will take the second boy that's 0. Because negative we normally have 3 did involving just to see becomes negative. More. We have values first because we will start from the least, and then we will have we can reorder the negative values from the least, which is -7, -5, and -2, and then we can also reorder the positive values in terms of the least first and then the greatest being last. So when we put these together, we will have -7, -5, and -2, and then we append the other one, which is 0, 3, 6, 14. This means we are moving from the least to the highest. Let's do a similar thing, but this time in order. When we are descending, it means we are writing the greatest value first before writing the least ones. So this time we will start with the positive values, which have the greatest values, and then we later write the negative ones. When we order the positive values, we will have 14, 6, 3, and 0. You can see that we have written the greatest value first before writing the least, which is 0. And then for the negative 2 is greater than the -5 and -7. So when we put these together, we will have the positive values ordered first, and then we will have the negative values following in that order. So we have rearranged this from the highest value to the lowest value. Let's now look at some operations involving integers. We will start with the addition of integers. Addition means we are simply increasing the value of a number. For example, if I have 2 plus 5, I'll have 7 because I've increased the two numbers. If I have -2 plus 5, it should give me 3. How did we find this? This looks a bit tricky. Let's use our number line to see how we can do this. Let's assume we have a number which is 1, and we are trying to add 3 to it. We just have to start counting after that number 1 3 times from the least side to the highest side. So we will have 1, 2, and 3. This means we have added 3 to the number 1. Note that we did not start from the actual number because we are increasing the value after the 1. So we will have our last dot ending on the number 4. This means 1 plus 3 is indeed 4. But what if we want to add -1 to that 1 that we have? That is, for our starting number 1, we are going to add -3 to it. Adding -3 means we are going to add a number which goes in the opposite direction. So we are going to start from our reference point, which is 1 again, before we add our -3. So once again we use our dot. This time we are going to move the dot from the right hand side to the left hand side, and this will be 1, 2, and 3. So we have added 3 negative numbers, and this ends on -2. That is why we have our answer being -2. Let's do a few more. Let's assume we want to start from 0 and add 4 to it. So we note our 0 and then we move one step and we start adding 4 dots. So we'll have 1, 2, 3, and 4. So we have added 4 dots. So our final answer or our final dot ends on +4. That is why we have our answer being 4. In this other example, we have been asked to find -3 plus 5. This means we start our calculation or our movement on -3 on the number line. We are then going to append 5 dots after the -3. So we are going to move 1, 2, 3, 4, 5 times. So we ended on +2, which means indeed our answer is correct. Sometimes we can change the positions of the numbers involved in the addition. Let's say we have -3 plus 5. We can rewrite this as 5 minus 3, which becomes +2. Let's say we are adding 2 to negative, and this will give us -3. Let's see how we got this. We will start from -5 and then move 2 paces after the -5. So we'll have 2 dots. We'll have 1 and 2, and this ends on -3. As I said, we can rewrite this as 2 minus 5, and this becomes -3 as well. Now let's add -3 to 0. This will give us -3. Why is this so? Let's start from our reference or starting number, which is 0, and then we are now going to add -3. This means we are going in the opposite direction. So we are going to append 3 dots starting from the right hand side to the left hand side. So we'll have 1, 2, and 3. So this gives us -3 because that is where the last dot ends. We can rewrite this as 0 minus 3, and this will give us -3 as well. Let's say we have 2 plus a negative number. We will start our movement on +2, and then we are going to add -6. This means we are going to add 6 negative dots. So we are going in the opposite direction. So we'll have 1, 2, 3, 4, 5, 6. And this gives us -4. This can be rewritten as 2 minus 6, which is -4. As you can see, when we are adding a positive number, we are moving from the left to right. That is in terms of the increasing value. But when we are adding a negative number, it means we are coming backwards, which means we are moving in the opposite direction of the increase. Let's say we have 2 plus -2, and this gives us -4. Why? Because when we start from the starting number, which is -2, and we add -2, it means we are. So we add 2 dots, and this ends on -4. We can rewrite this as -2 minus 2, which gives us -4. Let's now look at those involving subtraction of integers. Subtraction means we are decreasing the value of a number. So if I have 5 and I reduce it by 2, I'll get 3. What if I have 2 and I reduce it by I have -3? Let's look at a few examples involving this. Let's assume we are subtracting 5 from 3. This will give us -2. So let's place our reference point on 3. That is where we are going to start. We are being told to subtract +3 from this, which means we are going backwards. So we are going to count 5 steps after the 3. So we have 1, 2, 3, 4, and 5. So this ends on -2. Let's look at another one. We've been told to subtract +4 from 0. So our reference point is 0. And we are going to move back 4 steps from 0. So we will have 1, 2, 3, and 4. And this ends on -4. Let's do another one. We have 1 minus 3. Our starting point on 3. And then we move back 3 steps. So this will give us 1, 2, and 3. And that gives us -2. Okay, now let's try and appreciate something. Minus 3. This will give us negative 2, because when we move back 3 steps, we will end on negative 2. But what if we are subtracting negative 3 from the 1? In other words, we are doing 1 minus negative 3. This will mean we are this time and not backwards. That is, when two negative signs meet, we change their answer to become positive so that we can move forward. So our question will become 1 plus 3, which will give us 4, because when we move 3 steps after the 1, we will end on 4. I hope you appreciate this. So let's assume we want to do 0 minus negative 2. This means there are two negative signs involved, and we have to change their signs to positive. So we will have 0 plus 2, which is 2. On the number line, we will have to start from 0 and then move 2 paces after the 0. So we will have 2 as our answer. We are now going to focus on the multiplication of integers. Multiplication means we are increasing the value of a number by a certain factor. For example, I can use 2 to multiply 5 to give me 10. What if I also do 2 times negative 5? That should give me negative 10. Let's try and see how we can do multiplications involving. There are various rules that we must follow. If we have one positive number multiplying another positive number, the answer will be positive. For example, if we have A times B, we will have B being our answer. If we have a multiplication involving one of the numbers being negative, our answer will become negative. For example, if I have negative A times B, I'll have negative AB. Or if I have A times negative B, my answer will become negative AB as well. So long as there is one negative involved in the multiplication of two integers, there will be a negative answer. If we have two negative numbers multiplying each other, their answer will become positive. For example, if we have negative A times negative B, we will have positive AB as our answer. Let's look at a few proper examples. For the first one, we have positive A times positive B giving us positive AB. Let's look at a few examples. We have positive 3 times positive 4. The answer is positive 12. If we swap and we have positive 4 times positive 3, we will still have 12. The next one says, if we have negative A times B, our answer will be negative AB. So for our answer will become negative 12. Also, if we have 3 times negative 4, we will have negative 12 as well. If we have two numbers which are negatives multiplying each other, for example, if I have negative 3 times negative 4, my answer will become positive 12. We now move on to division of integers. Division means we are splitting or sharing a value equally by a number. For example, if I share 10 objects between two people, I'll have 5 equal parts for each person. Also, if I have 10 and I divide it by a negative number, I'll have negative 5. Let's look at some of the rules involving the division of integers. If we have A divided by B, we can rewrite this as A over B. So positive A over positive B, and this will give us a positive answer. If we have negative A divided by B, this will give us a negative answer. Or if I have a number divided by a negative number, I'll still get a negative answer. If I have negative A divided by negative B, I'll have a positive answer. That means if I have two numbers which are negatives dividing each other, the answer will be positive. Let's look at a few examples involving these rules. The first one indicates that we are dividing a positive number by another positive number. For example, if I have a positive number like 8 being divided by another positive number like 4, my answer will be positive, which is 2. If I have 4 being divided by 8, I'll still get a positive number even though this is a decimal. If I have a negative number being divided by a positive number, my answer will become negative. For example, if I have negative 8 divided by 4, my answer will become negative 2. Also, if I have 8 divided by negative 4, my answer will still be negative 2. Negative number divides the other, the answer becomes positive. So if we have a negative number like negative 8 being divided by negative 4, we will have a positive answer of 2. We are now going to solve some complex operations involving groups and mixed fractions. You remember when we studied about BODMAS, we said we must always start with braces first. That is, anything in brackets we have to consider first. And then we look through if we have exponents involved, and we solve those ones before we proceed. We may also have division and multiplication, which can be done at the next level. We may also have addition and subtraction, which can also be considered at the same line or level. And as we said, this must start from the top to the bottom in that order. Let's look at a simple example involving the operation of integers in groups. We assume we have this question to solve. All of these are integers. Some are negative, some are positive, and we have to carry out various operations on them to derive a proper answer. We use our BODMAS approach, so we start with the bracket first by considering what is in them, and then we proceed with our operations. Negative 2 times 4 will give us 8, and 16 divided by 8 will give us 2. So we'll have negative 8, which comes from negative 2 times 4 in the bracket, and we'll also have 2, which comes from a division of 16 by 8. So we can go ahead and do our additions and subtractions. Negative 8 plus 14 will give us positive 6, and then we will have our minus 2 coming down. 6 minus 2 will give us an answer of 4. The last section of this lesson involves the properties of operations of integers. We are going to cover the commutativity, or what we call the commutative property, the associative property, and zero property of integers. The commutative property holds that we can swap numbers in an operation involving the same number and still get the same answer. For example, if I have A plus B, I can rewrite this as B plus A, and my answer will still be correct. Let's look at an example. If I have negative 3 plus 2, giving me negative 1, I can swap the position of negative 3 and 2 and I'll still get the same answer. This means I'll have 2 minus 3, and this will indeed give me negative 1. You can see that the answers are both the same. The associative property holds that it doesn't matter how we group numbers in an operation, the outcome or the result will still be the same. For example, if I have A plus a grouping of B plus C, I can swap the grouping on A plus B and my answer will still be the same. Let's look at an example involving integers. Let's assume we have 3 plus into bracket 2 minus 4. The answer is equal to 1. And also, if we have the grouping on the 3 plus 2, this will give us 5 minus 4, which is also 1. The two answers indeed are the same. Let's look at the zero property. The zero property holds that if we are carrying out an operation involving two numbers where one of the number is 0, the result will still be the same. So if I have A plus 0, I can rewrite this as 0 plus A because the answer will still be the same. Let's look at an example. If I have negative 2 plus 0, it will give me an answer of negative 2. When I swap the positions, I'll have 0 plus negative 2, which is also going to give me negative 2 as my answer to this lesson on integers. I hope you have enjoyed it thoroughly. Goodbye and see you in the next lesson.